proteins bind to the lens and how the metals can alter the function of the protein. And some of my mentor information is down there. He's Professor at Loyola, and he's an eye doctor. So basically, what my research is about, what my research is focused on, is on heavy metals. And so what I found was heavy metals are part of our food chain, and heavy metal consumption is in minimal amounts is okay, but if it bioaccumulates, similar to Sarah's explanation yesterday, it can be very toxic. And so some examples of heavy metals are lead, cadmium, chromium, gallium, mercury, and I'm going to be looking at lead in particular. And so basically, going back to biomagnification, biomagnification is basically the increase in concentration of a certain substance in consumers as you go up the food chain. So here's a picture of, very similar to Sarah's, but I just took a picture. What happens is you have heavy metals, and you have pesticides sprayed on the food that the cattle eat, and then when we eat the cattle, the heavy metals kind of bioaccumulate in our food chain, and that's where it can become very toxic, because eventually that toxic waste doesn't leave our bodies. It stays in our bodies, and it gets stored in the fatty tissues. So some studies I found online that tested for heavy metal concentration in human eyes found that lead and cadmium in all pigmented ocular tissue was found in all pigmented ocular tissue, and this just shows that heavy metals can travel to your eyes. A lot of times it gets contaminated in blood, and blood travels all throughout our bodies, even to our eyes. So over there, you can that study also proves that that heavy metals can be found in the eyes. And another study tested the exposure of lead. As I'm looking at lead, I researched a lot on it, and they found that there's a lot of cellular damage in the hippocampus, amygdala, and cerebellum during certain period of brain development. And it was also concluded that there was damage to neurons in the hippocampus, so clearly that lead has a lot of toxic effects on prenatal and postnatal development. And so I researched lead as one of my main background things that I need to explain and look into. And then I also looked into zebrafish, because zebrafish is what I'm using. Last year I used pig eyes to look at the lenses, but this year I'm looking at zebrafish eyes, because this has to do more with the procedure, but basically zebrafish are a good model for experimentation because they're vertebrates, and they have a lot of, their genes are very common with ours, and that's what makes them a good test subject. And also because you can also mass produce them. It's really easy, and the more data you have, the more sufficient and the more better your data is. So if you mass produce and get a good amount of data, then, because last year I didn't have a good amount of data, I only had for a few lenses, I think it was 3 or 4, and I didn't have a sufficient amount of data. So looking at the zebrafish eyes will hopefully, zebrafish lenses will hopefully give me a bigger amount of data, which I can then prove to you guys. And then so basically my investigation is to test how the heavy metal concentrations can affect the proteins within the zebrafish lens. And then I predict that if the cells from the lens are exposed to heavy metals, then they will affect the proteins working within the lens. And those are some of my materials right there. I'm not completely sure about my preliminary procedure, as I'm going to be working with my mentors at Loyola. And so basically what I'm going to do is I'm going to determine how lead as a toxicant in the eyes of zebrafish lenses behaves, and what happens, and how it later on. And basically that's the literature side of it. And so some of my learning outcomes, again, some of my learning outcomes with my research. I looked at how the different parts of the eyes work and how they work together to help humans in their vision. And then I also learned about different metals having a toxic effect on the body in general, because I'm going to be looking at lead as a toxicant. And I also learned what happens to heavy metals once they're ingested in your body. They bioaccumulate, and that's what causes the toxicity. And some of the investigation outcomes I hope to learn is how to embed zebrafish eyes into keratin, and that's basically I'm going to be extracting the zebrafish eye lens and putting it into the keratin so I can kind of expose it to light and then kind of see the results of what that is. And then also I'm also going to be using this. I used the spectrometer last year, but I'm going to be using it again this year a little bit as well. So that will be the working element. And so currently my project has not been started, but it's in the process to begin. And basically human animal tissue use, it's probably mainly going to be zebrafish lenses, and some hazardous materials are just the different heavy metals if we decide to use them, but right now it's just lead. And so the implications of this study, so basically I did this project, a very similar project last year with cow eyes, and I was looking at how the big picture behind this project is to look at how cataracts are formed. And cataracts are not only formed in older people, but a lot of younger people get it, young adults get it. So it's something like ongoing, and I know there's a lot of research on like other diseases like cancer and like Alzheimer's. So I just thought this project is a little different, and it kind of focuses on something that a lot of people kind of just